Example 2. Constructing a confidence interval. Online courses. We noted that in a Sallie Mae survey of 950 undergraduate students, 53% take online courses. The sample results are n, which is equal to 950, and the point estimate, which is 0.53. So the first thing we have to do is the requirement check. Number 1, the polling methods used by the Sallie Mae organization result in samples that can be considered to be simple random samples. Number 2, the conditions for a binomial experiment are satisfied because there is a fixed number of trials, which is 950. The trials are independent because the response from one undergraduate doesn't affect the probability of the response from another undergraduate. And there are two categories of an outcome. An undergraduate either takes online courses or does not, and the probability remains constant. So because the probability of undergraduate takes online courses is fixed for a given point in time. So for number 3, we need to determine, does n times p, is that greater than or equal to 5? Well, it says 53% of 950 undergraduates taking online courses. The number taking online courses is 53% of 950, which is 504, because 0.53 times 950 gives us 54. Because if we take the 950, which represents our sample size, and multiply that by 0.53, well, that equals 504, which is definitely greater than or equal to 5. Okay, now we also need to take a look at the following. We need to take a look at the failures, meaning that for those that did not take the online classes. So if we know, and that's the point estimate here, so if we know that the point estimate is 0.53, well, the complement is 1 minus 0.53, which is then equal to 0.47. So that means if we take n and then multiply it by q, which is the complement of p hat, then we want to make sure that's greater than or equal to 5. So again, if we take a look at the sample size of 950 and then multiply that by 0.47, well, that gives us 446, which is greater than or equal to 5. Okay, so now that we determined that, we can say that the check of the requirements has been successfully completed. Okay, now in part A, what we want to be able to do is find the margin of error that corresponds to a 95% confidence interval. Okay, so the margin of error is found by using formula 7.1 with the critical value. Now, because we're using these table of critical values, we don't have to go through, because we know that since it's 95%, over here 95% gives us a critical value of 1.96. That's how we know that the critical value is 1.96. Now, if it was not 95% or 90% or 99%, then you would have to go through to find the z-score for that area. Now, we know the point estimate is 0.53. We know that the complement of the point estimate is 0.47, and then n is equal to 950. So now what we're going to do is we're going to plug it into our formula. So here, let's take a look. We know that the critical value is 1.96. We know that our point estimate is 0.53. We know the complement of the point estimate is 0.47. And we know that the sample size is 950. So what we're going to do is, let's go ahead and do this on a calculator. So the best way to do this on a calculator is the following. Do what's inside the radical first, because you want to follow order of operations. So looking at the numerator, we're going to say, okay, 0.53, and then we're going to multiply that by 0.47, and then enter, and then we're going to divide that by 950, and then that's going to give us our answer. So we want to take the square root of that answer. So I'm going to go second square root, and I'm going to go second, and then the answer, and then hit enter. And then I'm going to multiply it by 1.96. And then that gives me 0.317381115. We just cut it off at the 1. Now, that's the margin of error. Okay? Now, we want to find the 95% confidence interval estimate of the population proportion P. So, constructing a confidence interval is easy now that we know that the point estimate is 0.53 and the margin of error is 0.0317381. Now, take note, I did not round the margin of error because we don't want to round it until the very end here. So, we're going to take the value of the point estimate. So, the point estimate is P, which is 0.53. And then what we're going to do is then subtract the margin of error on the left side and then add the margin of error on the right side. So let's go ahead and do that. So using our calculator, we're going to do the following. We're going to take 0.53 and then we're going to subtract 0.0317381. Okay, and we get 0.498261. Now we want to round that to 3 decimal places. Let's do the other side now. We have 0.53 and then plus 0.0317381. And then that's going to give us 0.562 because you want to round that to 3 decimal places. So therefore, you're going to see the following. You get 0.498 and then 0.562. Now, the same result could be expressed in the following format. We can say that 0.53 plus or minus 0.317381, or in an interval notation, we would have left parentheses 0.5498, comma 0.562. Now, if we want the 95% confidence interval, or CI, for the true population percentage, we could express the result as a percentage by multiplying both of these numbers by 100%. So we would say P is between 49.8% and 56.2%. Now, based on the results, can we safely conclude that more than 50% of the undergraduates take online courses? Now, based on the confidence interval obtained in Part B, we cannot safely conclude that more than 50% of undergraduates take online courses because the confidence interval ranges from 0.498 to 0.562. It is possible that the population percentage is below 50%. Now for Part D, it says, assuming you are an online reporter, write a brief statement that accurately describes the results and include all the relevant information. So here is one statement that summarizes the results. 53% of undergraduates take online courses. The percentage is based on Sallie Mae survey of 950 randomly selected undergraduates, and in theory, in 95% of such polls, the percentage should differ by no more than 3.2 percentage points in either direction from the percentage that would be found by interviewing all undergraduates.